Have you ever seen a marble run like this? It took 6 months to create, from concept to completion. Why did it take so long? Well, the central idea sounded simple at first. Let's have people walk underneath the marbles. But that simple idea drove a complexity that went far beyond just building a few bridges. This is the story of my largest and most challenging marble run. And here's a challenge for you. Count how many times you see the Mass Marble logo in this video and write your answer in the comments. No, not including this time. This is just so you know what the logo looks like. My client PX commissioned me to design a marble run for their expo booth at LeadsCon 25, a conference at the MGM Grand in Las Vegas. They wanted it to visualize how their company connects various players in the lead generation industry. After 6 long weeks of brainstorming ideas, we settled on a layout of 4 separate tables, connected by bridges carrying marbles between them. It sounded like a straightforward idea. And after signing the contract, I had 4.5 months to design and build the marble run. No problem. Or so I thought. But people have an almost universal tendency to underestimate the true complexity of things. For example, some cosmologists believe that the existence of life on other planets is as simple as just add water. But the assumption that water begets life overlooks the massive amount of design coordination necessary to produce the sophisticated biological machines that perform critical life processes. It's just so easy for us to gloss over the nitty-gritty details that pose significant challenges when building systems like this that are composed of multiple interacting components, and that includes this marble run. To be honest, I underestimated the complexity of this project, and it almost got the better of me. There were so many individual details to address, involving thousands of Lego and Gravitrax parts. Before long, I was seriously questioning if it was possible to finish this project on time. Of course, I knew we needed towers on each table to run bridges over people's heads, and I had built towers out of Gravitrax before, so that seemed fairly simple. But I needed a way to tie together the tower's pieces to prevent them from falling apart when the tower was moved. So I 3D printed hundreds of these pins that snap into the slots of Gravitrax pillars, anchoring them to each other. I also designed a system of 3D printed girders and gussets and pins that lock together Gravitrax pillars and walls so they can't pull apart. Next, it was time to light up the tower walls, so I made these snap-in strips and mounted LEDs on the back so the light would shine inward. Oh yeah, that looks amazing. I love light. On top of each tower, I added some of the coolest decor ever invented, MOVA globes. The 3 small tables feature 6-inch diameter moon globes, and an 8.5-inch diameter sun globe graces the center table. Placing the globes on clear acrylic tubes made them appear to float on air. MOVA globes are solar-powered spheres that spin on their own without wires or batteries. They make great corporate gifts, graduation gifts, birthday gifts, decor for your library, and fascinating centerpieces. MOVA globes are available in different prints. They have all the planets, lots of different Earth designs, Major League Baseball teams, and even some art. And they are a lot less expensive to own than the Las Vegas sphere. I want to thank MOVA globes for donating the 3 moon globes used in this project. And I encourage you to get your own MOVA globe using my affiliate link in the video description. If you use my special discount code MARBLE, you'll save 10% off the larger 6-inch and 8.5-inch globes when you check out. Save the code, it doesn't expire. Next, I designed these covers to hide electronics in the tower bases. The covers have holes for ventilation because the solid-state electronics inside are passively cooled. Inside each tower are a power strip, 3 power supplies, 4 LED controllers, 2 LED signal amplifiers, 4 DIN rail blocks for wiring connections, and a USB hub to power the marble lifts and color sorters, which I'll tell you about later. It was still a challenge to get everything to fit. An even greater challenge was the marble bridges. My first thought was to design some transparent acrylic bridges, so I sketched up a couple in Tinkercad, one with Plinko pegs and another with zigzag strips. But as every product engineer knows, in order to build your design, it must be producible. And since the longest acrylic sheets at local plastic supply shops were 8 feet long, that would limit bridges to 8 feet. And that meant the entire tower layout had to get much more complex, adding additional towers to the center table so the bridges could reach. And this highlights how much harder it is to design systems whose components are interconnected, because if you change one part, the interconnected parts also have to change to keep the system interactions working. You can't produce such systems using a Darwinian design approach. In other words, you can't use a serial decision-making process that makes slight changes one after another with no foresight about where those changes are taking you. That's because changing one small thing at a time will repeatedly break the system, not optimize it. Instead, the complex interconnectedness of interacting parts requires a parallel decision-making process where coordinated changes are made to multiple parts in tandem, guided by foresight to steer the system towards the desired outcome. But it turned out the acrylic bridges would exceed our budget anyway. So plan B was to buy some clear 8-foot polycarbonate tubes for the marbles to roll through. They even come with an aluminum channel on top to mount an LED strip, which is a cool idea. But the more I thought about it, the tubes just don't look bridgy enough. I really wanted a marble bridge that looks like a bridge. Then I saw a video that gave me an amazing idea. This guy created a working Lego crane that reaches 7.3 meters high. That's 24 feet, as tall as a 2-story building. Not only did these trusses look more bridge-like, but by making them 10 feet long, I could move the towers back to the center of each table, simplifying the layout. The next challenge was to get marbles across the truss bridges. If I use Lego tiles, no one can see the marbles from underneath. Well, there's only one way to solve a problem like this. Hop into the Mass Marble Development Lab and create some new Marble Run tech. I did some super cool marble development stuff that I can't really talk about, mainly because it involves time travel. 9. Time travel is impossible because there is no absolute coordinate system in the universe. Everything is relative. A person traveling through time would end up in a completely different place, like in outer space or a kilometer underground. It would kill the man. And even if you could transport a person to a precise location in a different time, what would you do with all of the air in that location? How would you push it out of the way? You cannot just leave it there. It would kill the man. What if you accidentally transported the person to a space occupied by a dog, creating a real-life dog man? It would kill the man. After some time in the lab, I figured out that by assembling these transparent wall panels in an offset square pattern, it creates a transparent marble tunnel. Suspending these tunnels underneath the bridges ensures marbles can be seen from below. And of course, the bridges need lights to illuminate the marbles, so I 3D printed these long pieces with brick studs that attach LED strips to the Lego bridge. To transport the bridges, half of the strips can be folded back. Then the bridges split in the middle, giving 5-foot bridge sections that fit in the van. But then, a major glitch turned into a nightmare that almost submarined the entire project. I ordered 1,800 transparent wall panels to build the marble tunnels, but when they arrived, the pieces were too scratched to be used. Webrick's website said their premium pieces were in stock, but premium parts would take months to make. This was so stressful. Any more delay and the project wouldn't be finished in time. I switched to non-premium bricks, but then they forgot to use express shipping, and by the time the parts arrived, the convention was only days away. While that drama was unfolding, I needed to find a way to attach bridges to the towers. I used this free website tool to design custom brackets that are compatible with Lego Technic and attach them to special girders using Technic pins. The bridges drop in place and are secured with Technic axles. Next, I needed a way to lift marbles up from the tables to cross the bridges at the top of the towers. Gravitrax lifts aren't even 3 inches tall, and I needed a 5-foot lift. And stacking Gravitrax lifts wasn't an option because marbles will stall if the lifts are even slightly out of level. In retrospect, I should have 3D printed my own marble lifts, but at the time I thought it would be easier to build them out of Lego, using some existing designs for great ball contraptions. I was wrong. Again, I underestimated the amount of work it would take to build these. You can't simply take existing lift designs and stack them on top of each other. I had to significantly redesign the lifts and add supporting scaffolding. For the front 2 tables, I decided to use a couple conveyor lifts. Now I needed 2 lifts for the center table. I started by building a serpentine lift. I had to increase the thickness of its front face and add scaffolding to make it sturdy. And of course, this meant a lot of associated changes, like longer axles and changes to the gearbox. The lift contains about 50 gears, so it needs 2 motors. This meant adding Lego clutch gears to allow for slippage. The serpentine lift hooks over the top of the tower and is positioned at the bottom using these 3D printed pieces with studs that attach to the bricks. My most ambitious lift build was this dual-sided bucket lift. It also has 50 gears and 2 motors, but it was a challenge to get it tuned correctly. The build required a lot of custom tweaks before it was running smoothly. I powered the lifts with these rechargeable battery packs from AliExpress. I like that they have speed control built in. There was still so much to design. First, I needed a way to transfer marbles from the lifts to the bridges, so I designed a catcher with holes through which the marbles would drop onto a ramp and then out a Gravitrax rail to a Lego adapter and into the bridge. Once marbles had crossed the bridges, I needed to get them down the towers, so I printed this marble spiral and this random path descent using a translucent filament. I ran an LED strip through the middle of each and lit them for dramatic effect. I also built this Lego cheese slope spiral, which is seriously a lot of fun to watch. For the front 2 tables, I wrapped tracks around the towers, allowing the marbles to spiral down. But since the Gravitrax system doesn't have an easy way of attaching marble tiles to the outer edge of pillars, I 3D printed these clip-on and snap-on balconies, which let you place marble tiles almost anywhere on a Gravitrax pillar. The next challenge was to get marbles from the bridges to the descents. I 3D printed some catch bins, but then discovered the momentum of marbles coming off the bridge caused them to bounce back inside. So after this failure, I designed these Lego baffles, which redirect marbles inside where they rattle around in a confined space, dissipating much of their kinetic energy. They worked pretty well, and at the expo only malfunctioned a couple times when marbles piled up too fast. So now I was finished with the marble run design, and nope, I still had to design the marble runs on the tables, and this was more difficult than normal. I had decided to use slightly larger 13.8mm diameter plastic marbles instead of the 12.8mm steel Gravitrax marbles because the plastic marbles are more colorful and bright. But since plastic marbles are lighter, I needed a steeper slope on the marble run to prevent marbles from stalling. And even though the marble run designs worked great in the masked marble development lab, the Expo booth's thick carpet pad prevented the table vendor from perfectly leveling the tables. So at the convention, marbles did not roll as intended, and almost every track required adjustment to get it to work. Most of the tables in the booth had marbles going up a lift, across a bridge, and down the tower on the next table. But on the back table, marbles simply went through a turnaround and headed back to the middle table. This turnaround had worked great in the lab, but at the expo, marbles actually backed up a few times due to differences in bridge position between the lab setup and the expo setup. Like I said earlier, small changes tend to break interconnected designs. One of the coolest parts of this marble run were the color sorters. This marble run was interactive, so conference attendees could drop in a colored marble and follow it through the track. So I used Lego Spike robotic kits to sort marbles depending on their color. A Lego sensor would detect marble color or reflectivity, then motors would redirect marbles to the correct output. Since black and white marbles have the same chromacity, or lack thereof, the sensor could only tell them apart by comparing their reflectivity. I made all the white and colored highly reflective marbles go to the right, while black non-reflective marbles representing rejected leads headed to the left. At the end of the marble run, I used a 2-stage color sorter in color sensing mode to send most of the colored marbles to 4 separate landing bins, recirculating white, black, and green marbles back through the track. But the color sorters only worked well if the marbles had some space between them. If marbles bunched up, they could end up in the wrong place. The back table hosted a self-contained marble run consisting of a small conveyor lift and a logarithmic marble counter. 10 marbles accumulate in the ones place, then 9 of them dump out into a 3D printed funnel, while the 10th marble drops to the tens place below. Every 10th marble in the tens place drops into the hundreds place, and so on to the thousands and 10,000s places. The entire exhibition only lasts a day and a half, which is less than 50,000 seconds, meaning the 10,000s place would never fill up.
Oh wow. That is cool.
With perseverance and God's help over months of work, the marble run was finally completed, and it drew a lot of traffic to the booth. And in that sense, the project was successful. But this marble run was so much more work than I anticipated. And even at the expo, it just seemed like all the little nuisance problems would never end. I had to monitor the track and correct issues most of the time, and as an engineer, I admit that was disappointing. But there were times that the marble run ran without hiccup for 30 minutes or more, and I could sit back and take it all in. I fail at something every day. It has taken me decades to start appreciating that this process of failing is how I learn and grow. With this project, I tried building a marble run that had never been done before, and it was really hard. It didn't work perfectly, but it got done. And through doing this, I gained more expertise that I'll carry with me. Everything learned from failure produces a better outcome for next time if we cherish the lessons learned instead of recoiling at their memory. And that means the failures are ultimately good. So embrace the process of trying and failing. Maybe it's time for you to fail at something new too. I can't wait to see what you come up with.
You guys crushed this.
Thank you.
With the setup.